let's try running Edsim51. And what you can do is open up like what I did, and then type in the code. Say, wow, really? Type in the code, huh? Okay, what language is this? ORG000H, MOV 90H, # 24H, END. Okay, so those of you who took my C programming class last semester say, hey, that looks kind of like assembly language. Yes, it is assembly language. What's assembly language? Well, it's just one level above machine code. It can be translated to zeros and ones so that the microprocessor can understand and run it. Okay, so it's almost one-to-one. So let's try this. So let's go back to the Edsim window, and then what do I do? No, ORG and then 0H. That's good enough. And then what code is it? MOV P1, comma, right? No, okay, 90H, really, it's, okay, P1 is the same, # 24H, okay, END. And, okay, everybody saw how I did it? P1 gets translated to 90H, let me just tell you that. And that's it. So what you can do is assemble and no error. So it turned into this form that you can select, but you can't type over. And then now here's a run button. Okay, and then if I click on run, oh, did you see something? See down here, it's turned red. Turns into like a 2, right? Okay, so yay, that's our Hello World program. Okay, so as you see, well, this is one way to write your assembly or your embedded system program. Of course, you're not going to be writing most of your code like this, because this is, wow, this is, I don't even understand it. I'm a senior by now. I've seen many programming languages. I've never seen anything like this. What's going on? Well, it's not that bad. Okay, but you'll get a lot of practice, at least for a couple weeks, just so that you're comfortable with this level of programming. But to write a program like this, you have to know what the hardware, know the hardware context. Okay, and so once you know it, then I think you can write better code, or you can write code with much better control of what's going on. Okay, so okay, so yeah, that works. Okay, click ASM and run, and so there. So that's one extreme of how you can write code for an embedded system. In fact, this is how people used to do it 30 years ago. Even though C language has been around for a long time, since the 1970s. I think it took a long time for people to finally accept C for programming. But that doesn't mean you shouldn't know anything about assembly. In the end, we'll let you use C. And even higher language, I'll show you even better, cooler things I've been working on myself. And that you can type in directly to a little board like this. And but no, it's good to know assembly level, just so that you have better control over what you're writing. Okay, so that program wouldn't make any sense unless you know the hardware context. Okay, so this is what's called a schematic or circuit diagram that corresponds to the hardware that's being simulated. Okay, and this you can find on the Edsim51 website, or if you buy that book, they'll also show this. So as you can see, there is a box called Edsim51. I don't know if you can see easily. Let's see if I can zoom in. Oh yeah. There we go. Okay. See, 8051. There. That's your microcontroller. And microcontroller is a little microprocessor on the inside, but it has input and output interfaces on the outside. And you see on its lower left, there's P1.7, P1.6, P1.5, all the way down to P1.0, right? Those are the general purpose I/O pins. What that means is if your software writes to some register, then those values will show on the pins. Okay? That's something your traditional microprocessor couldn't do. Remember, if you have registers, you write or read, it's all in software. On the outside, you can't see that, right? But here, these values show on the pins. Okay? And so that's what allows you to turn on or turn off the LED segments. Okay? And so those are connected as wires to there's the 4 boxes there, right? So there's display 3, 2, 1, and 0. So each one is that 7-segment LED. Okay, and so that's how it can electrically control these. But then you say, hey, that's kind of strange. I mean, I wrote hex 2-4, right? 2 is what? You guys know hex, right? 0, 0, 1, 0. And 4 is what? 0, 1, 0, 0, right? And so if you check the 7-segment LED, like there's the what they call A, B, C, D, E, F, G. So A is the top segment, B is the right top, C is the one below it, D is 0, E going up. So it's a clockwise order, and then G is the middle one, H is that little dot. Okay, so and isn't it kind of backwards? Because all the segments with 0 lit up, whereas all the segments with 1 actually are off. So, hey, that's kind of strange. Why is that? Well, it has to do with the way it's connected electrically. So this is something I think software people have to get used to. There are reasons for connecting things backwards. That's because your general purpose I/O pins are not really meant for supplying power. They're just signals. Okay, their purpose is to provide a digital value, not necessarily to drive or to turn on. Not enough power to power like the light. And each LED segment consumes quite a bit of power compared to what the microcontroller can do. But okay, anyway, just to give you a brief overview, we'll go over these much later, so you don't have to. But I'm just pointing out, a few things you should pay attention to as software programmers. So oftentimes you'll see kind of strange things like this. Kind of zeros and ones are backwards from what you might expect. You might think 0 means turn off, 1 means turn on. But with embedded programming, a lot of times it's really the electrical consideration that forces you to have to do things backwards. Okay, and you have to know the reason why. Okay, so that's why I think it's important. This is really is an example that highlights the need to really know what's going on in hardware, so that you as a software programmer can really build a more efficient system. Because if you don't do this, that means you add a few more chips just so that you can use 1 for on, 0 for off. And that consumes even more power. That's unnecessary. Okay, so this is where the hardware level decision kind of works its way to the software side. And you need to know good reasons why that's done that way. Okay, and there are many other examples, but I'm just showing you. And this is actually pretty standard too.